Hello, programmers. This discussion introduces arrays as used by C and C++. An array can hold multiple pieces of data of the same type. The position in an array is called an index. The first position in an array is at index 0. Here is an example. Declare an array of 10 integers. Int score. Open square bracket 10, close square bracket, semicolon. With the comment, score can hold 10 integers. The index values for the array go from 0 to 9. Since the index starts at 0, index values for an array of 10 elements are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Trying to use a negative index value or a value of 10 or higher would be an illegal attempt to access locations that are not in the array. Array index starts from 0. It is most common to start counting from 0 because the first index or position in an array starts with 0. This may be confusing for most Americans who count the ground floor as the first floor, but the rest of the world counts the first floor as the floor above ground. Index values start at 0 because it is easier to internally compute the address of individual elements by adding the index number times the element size to the starting address of the array. The first example shows only that an array of 10 integers has been declared. The square brackets are used to identify an array. Enough room in memory is reserved to store 10 integers. If the array is declared as an automatic variable inside a block of curly braces, then the contents of the array are not initialized. This means that they are full of garbage data that happened to be in those memory cells before the array was declared. It is up to the programmer to place some known values in the array elements before trying to use them, increment them, etc. If the array is declared with the static keyword, or if the array is declared as global data outside of any block of code, then the contents of the array are initialized to zeros. The second example shows an array being declared with 10 integers, and the contents of the array are being initialized at the same time. The curly braces are placed around the initializer data, and each element is separated by a comma. If an array is initialized when it is declared, it is not necessary to give the size of the array. The size of the array is determined by the number of elements listed inside the curly braces. The C and C++ compilers need to know the size of an array when it is declared. Here is an array of 10 integers. For most compilers, the size of an integer is 4 bytes, so the size of the array would be 40 bytes. The size of operator can be used to determine the size in bytes for data types, arrays, and other things. The size of operator can also be used to determine the number of elements in an array by taking the size of the array and dividing it by the size of each element in the array. If the size of an array is declared and the array is initialized with fewer elements than the size of the array, the remaining elements are set to zeros. An individual element in an array can be accessed by giving the name of the array and placing the index number of the element inside the square brackets. In these examples, X gets a 7 from index position 4, Y gets a 10 from index position 5, Z gets an 8 from index position 1. The index into an array must be an integer data type, which in C and C++ includes the character data type. An error will happen if trying to access elements before or after the end of the array. The index can be an expression. In this example, n is a 3, so n plus 1 is a 4. Therefore, X gets a 7 from location 4. This is a very common way the for statement is written when working with arrays. Notice that the index I starts at 0 and goes up to but not including 10. The test statement in the for loop is I less than 10 semicolon. This for loop is being used to compute the total of all the values that are in the array and then compute and display the average score. Now that we are working with arrays, it might make more sense why it is most common to count for loops starting at 0 and going up to but not including the highest value. Here is a fantastic reason to use constants. The same constant is being used when declaring the size of the array and also used inside the for loop to increment through the array. If class size ever changes, it will be changed in every location that it is used. What would happen if you just used the number 10 and forgot to change one of them? Or even worse, if you wanted to change the size of the array from 10 to 12 and then used find and replace in the editor to change all the 10s to 12, a value of 100 would also be changed from 100 to 120, and a value of 7108 would be changed to 7128. This is probably not what would be desired, but unintended find and replaces have happened to me. In this case, the loop moves the index from 0 to 10 because the test in the loop is I less than or equal to 10, which includes the index value of 10. The last position in the array is 9. The program will either report an error or, even worse, store something in memory past the end of the array, probably on top of some other data without any warning. It may be hard to find out why data in a different part of the program got changed when that part of the program looked okay. Arrays can have more than one dimension. Here is an example of a single-dimensional array. It is created for one student with 5 scores. Int student scores, open square bracket 5, close square bracket, semicolon. Now, let's create a double-dimensional array that can hold 9 students with 5 scores for each student. Int class scores, open square bracket 9, close square bracket, open square bracket 5, close square bracket, semicolon. Suppose I was teaching 3 different classes with 9 students in each class, and there are 5 scores for each student. Int school scores, open square bracket 3, close square bracket, open square bracket 9, close square bracket, open square bracket 5, close square bracket, semicolon. Starting with a single-dimensional array, I have int student scores, open square bracket 5, close square bracket, semicolon. The data in this array that shows 7, 9, 7, 7, 7 is not initialized when the array is created. For this example, the data would have to be placed in the array by code when the program is being run. Here is an example of creating a double-dimensional array for 9 students with 5 scores for each student. Again, the data in this array does not exist when the array is initially declared. Look closely at the square brackets when the array is declared. The first set of square brackets are used to define the number of rows, and the second set of square brackets define the number of columns in each row. This may be different if you are used to some other programming languages which would declare a double-dimensional array using parentheses and use a comma between the row and column definition. In Visual Basic, the array would be defined as dim, class scores, open parentheses, 9, 5, close parentheses, as integer. Let's progress to defining a 3-dimensional array. I might want to do this if I had 3 classes and 9 students in each class with 5 scores for each student. We are again using separate sets of square brackets when defining the multi-dimensional array. Another alternative to multi-dimensional arrays would be parallel arrays. Here I am declaring a separate array for each student. Although it is not too bad if there are only a few parallel arrays, it gets really messy as the number of parallel arrays grows. Look closely at how the curly braces and commas are used when initializing a double-dimensional array. There is an open curly brace for the entire array, and then separate blocks of open-close curly braces for each row. Commas separate the individual data for each row, and a comma is placed after the curly brace for each internal row. The double-dimensional array is finished with a closed curly brace and a semicolon. The spaces or tabs when initializing data are optional. Just add spaces and tabs to make your code as readable as possible. You can place the data on one or more lines in your program for easier reading. Just remember where the curly braces and commas are placed when using multiple lines, and then use the same organization on fewer lines. Here is a short code fragment that uses nested for loops to compute the average score for all the students in the class. This time, I'm using constants to define the dimensions of the array. It is called a code fragment because it is missing the #include, main open close parentheses, and curly braces for the block of code for main. Before the outer loop starts, the class total is declared and initialized to 0. The outer for loop is going down through the rows for each student. The inner for loop is getting each quiz score for a student and adding it to the class total. When the inner for loop ends, the outer for loop moves to the next student, and the inner for loop is run again and continues adding scores to the class total. Finally, when all scores have been added into class total, the cout at the end displays the class average is, and then the average, which is computed to be the class total divided by the number of scores for all students. The number of scores for all students is the product of students times quizzes. This concludes the introduction to arrays as used by C and C++. Bye for now.